Hello everyone, welcome back to my YouTube channel. My name is Shreya, and today I will be talking about open sets. First, I will go over some examples, then I will go over the formal definition of open sets and some properties that they hold. So let's get started. The open interval between 1 to 5 contains every single value between 1 to 5 except for 1 and 5 themselves. So that's represented by this number line right here. Notice that I haven't drawn 1 or 5 because they are not a part of this set. So if I look at my value 3 right here, I can draw some sort of a shaded region around 3, like so. Notice that this highlighted region that I have just drawn is contained within my number line. Now let me go kind of really close to the edge. So let's look right here. This must be 1.1. And I can draw some sort of a highlighted region around this point right here. Notice that this region is extremely small. However, it is still contained within my entire number line. Okay, so I want you to hold on to that thought. So now let's look at a two-dimensional case. Here we have y greater than x squared. So in other words, that is equal to the set S. So every single coordinate, x, y, such that y is greater than x squared. So that's what you see right here. And note that this is a dotted line, this parabola, because we are not looking at the values that are actually on the line. We are only looking at the cases where y is greater than x squared and not equal to x squared. So within this pink shaded region, let me draw this dot right here, and I can draw some sort of a circle around it. This entire circle is contained within my shaded region. Now let me go somewhere close to the edge as well. So I can go right here, and I've drawn a small circle around it here. It's small, but it still fits within my shaded region. And I can do that for here as well. I can draw a small circle, and that still fits within my shaded region. So the reason why I have been drawing these shaded regions is because this idea is very integral to our actual definition of open sets. So let's go over the formal definition now. Let's take set X. If X is an open set, then for all elements X in X, there exists some value epsilon that is greater than 0, such that x minus epsilon, so the open interval from x minus epsilon to x plus epsilon, is contained within my set X. Therefore, for any single x I pick in my set X, I can draw some sort of an epsilon neighborhood around it, and it should still be contained within my set X. Note that this doesn't have to be true for every single epsilon. There just has to be one epsilon that must satisfy this. So now let's look at some properties of open sets. The first property is that the finite or infinite union of open sets is open. So let's use an example to illustrate this. So I can take the union from 0 to n, where n goes from 1 to infinity. This is essentially the union from 0 to 1. You take the union of that with 0 to 2, union 0 to 3, and you go on. And this is just equal to the open interval from 0 to infinity. Essentially, we are looking at all positive reals. This is an open set because I can take every single element in this set, and I can draw some sort of an epsilon neighborhood around it, and it'll still be contained within this set. Now let's look at the second property. the finite intersection of open sets is open. So for an example, I can take -1 to 1 and take the intersection of that with -1/2 to 1/2. This is just equal to the open intersection from -1/2 to 1/2, or the negative interval from -1/2 to 1/2. This is an open set again, based on the definition that we have defined. So you might be asking, well, Shreya, in the previous property, we said both the finite or infinite union of open sets is open. Why doesn't that hold for intersections? We can show this using a counterexample. So let's take the infinite union from -1/n, from -1/n to 1/n, where n goes from 1 to infinity. So essentially what we're looking at here is -1 to 1 intersects with -1/2 to 1/2, intersects with -1/3 to 1/3. So my number line gets smaller and smaller and smaller and is constantly centered around 0. So if I just take the infinite intersection of that, I will just get the set containing 0. Now, this set is not open because even if I take a super small epsilon value, if I let epsilon be equal to 1/100, then that interval will not be contained around 0. So what will that interval be? I'll have 0 minus 1/100 to 0 plus 1/100, which if we simplify it, that's just -100th to 1/100th. And this interval is not contained within this set. Therefore, 0 is not open. So that's all we have for today's video, guys. If you liked it, then please like, share, and subscribe to my channel. If there are any other mathematical concepts that you would like me to speak about, then please leave a comment under this video. And in the next video, I will be talking about closed sets, and I'll be going over the definition and some of the properties that they hold. Thank you.